Now in this video we discussed the cycloid. So first we understand the definition of cycloid. See the definition. Cycloid is the locus of a point on the circumference of a rolling circle which rolls without slipping or sliding along a fixed straight line. A rolling circle is called the generating circle and the straight line is called the directing line. Now we discuss the application of cycloid. The first application is profiles of gear. Let's see the example. See, this is the profiles of gear. Second application, ball rolling down. Let's see example. Okay, so this is the example. This is the pure example of cycloid. See the curve, trace line. Now, third application, non-harmonic oscillation. Now we discuss the example. Draw a locus of a point on the periphery of a circle which rolls on a straight line path. Consider the diameter is 15. So step number 1, draw the circle of diameter 50 mm, or we can see the radius is equal to 25 mm, and marks its center as a C. So first we have to mark the point here. Okay, so this is the 25 mm. Here we consider radius is 25 mm. Now we have to draw the circle. Here, so this is the 50 diameter. Now step number 2, mark point P as the generating point on the circumference of the circle. So this is the generating point. Step number 3, draw the line of the length pi d, or we can say 2 pi r. This is circumference of the circle. Pi d is equal to 257.08 mm from the base of the circle to the left or right. So here, most important point, if the circle rotates clockwise, then draw the line right hand side. So here the circle is rotating the clockwise, so we have to draw the line in this direction, the right side. If circle rotates anti-clockwise, then draw the line left hand side. If circle is rotating anti-clockwise, then we have to draw the line this side. So here we consider the circle is rotating the clockwise. So here we have to draw the line is 157.08. Okay, so this is the generating point. So this is the distance 157.08 mm. Now we have to draw the straight line. Okay, so this is, we can also say this is the directing line. Now this circle we have to divide it into 12 equal parts. Let's see. Okay, so here we divide into 12 equal parts. Okay, now we apply the numbering 2012. Step number 5. Draw the horizontal line through points 1, 2, 3, 4, 5 and 6. So this is where we have to draw the horizontal line. Now step number 6. Divide a directing line into 12 equal parts and name the points 1 base, 2 base, 3 base up to 12 base. Okay, so this is our directing line. So this line we have to divide into 12 equal parts. Okay, now draw the line perpendicular to the directing line at the point 1 to 12. So here we have to draw the perpendicular line from all the points. Now mark C1, C2, C3 up to C12 where it is intersect the center line respectively. Okay, so this is our C1 point, C2 point, C3 point, C4 similarly C12. Now next step, take radius is equal to 25 mm or take the distance CO to P. Okay, so this is our center point CO to P, or we can say radius is 25. Step number 10. Now take this radius and consider the center C1. Cut an arc to the horizontal line which is drawn through the point 1 and mark P1. Similarly mark P2, P3 up to P4. So here we have to consider C1 is a center and cut the line first. See, it's very simple. Okay, so this is our center. Now we have to cut the line 1 of here. Okay, so this is our 1 point. Similarly, now consider the center as a C. Okay, and cut and arc the horizontal line, the point number 2. This is P2. Similarly, C3 line. Okay, C3, this is P3. Now C4 is the center. This is P4. Now center is P5. This is P5. Now center is P6. Okay, here but the line is 6 number. Okay, so this is the P6. Similarly, P7, P8, P9, P10, P11 and P12. Same procedure we have to apply. Now step number 11. Now all the points from P1 to P12. Just join all the points for a smooth top to make the required cycle. Okay, so this is the cycloid. Okay, it's very simple example. Thank you. For any query or suggestion, you can follow me on